Hello, and today we're going to be talking about the cosine rule. So first we have to actually get the cosine rule. So what we have here is a triangle, and I'm going to start by splitting it in such a way that's a right angle. We've done this before with the sine rule, we're doing it again. I'm now going to label this D. I'm now going to label the sides as well. So this is C, this is A. This side here completely is B. But I'm going to call this side X and this side B minus X. So that way we don't have to use two different values for the same when we can just use one. So now I'm going to work out what X is first. So I'm going to look at triangle ABD. Well, we can say cosine of A is equal to the adjacent X over the hypotenuse, little c. Then we can times c by both sides to work out what X is. So X equals C times cosine A. So I'm going to leave that there for now, and we're going to move on to the next bit. So still from the same triangle, I'm now going to use Pythagoras' theorem, and I want to work out what this dotted line actually equals. So I'm going to call this line H, and let's get started. So A squared plus B squared equals C squared. So what can we fill in here? Well, the hypotenuse still is C over here. Our A and B can be whatever we want, so I'm going to make H equal A, so we have H squared plus X squared equals C squared. I'm now going to transpose, so H is going to be our subject. H squared equals C squared minus X squared. And with that, I'm going to leave it there. I'm going to look at the other triangle BCD. So from BCD, I also want to work out what H squared is. So what's our hypotenuse here? It is A, so A squared. And we said that A was equal to H, so let's keep that. So H squared plus B minus X squared. So now I'm going to transpose again. So H is by itself. H squared equals A squared minus B minus X squared. So now I have two equations that equal H squared. I'm now going to use those two equations to equal each other. And I'm now going to move over to this side. So I now have A squared minus B minus X squared equals C squared minus X squared. So now I want to get X in there somehow, but to do that I want to expand this first. So A squared minus, in brackets, so what's B minus X squared? Well, if you know from quadratics, this is just 2bx plus x squared, which equals c squared minus x squared. Clean that up a little bit. So now we still have this negative to deal with, so let's make everything here a negative version. So a squared minus b squared plus 2bx minus x squared equals c squared minus x squared. So now we have a minus x squared on both sides. We can cancel those out. And now we're left with a squared minus b squared plus 2bx equals c squared. I'm now going to transpose all of this to the other side, so I'm left with a squared is equal to b squared plus c squared minus 2bx. So now I can sub in what x is from what we already worked out here. So we now have a squared equals b squared plus c squared minus 2bc cos a. And you can put a box around this little thing here, because this is what we were looking for all along. This is the cosine rule. And there's various other ways to write it. You can just, depending on how you labeled your triangle, you can also write it in different ways. So you can say b squared is equal to a squared plus c squared minus 2ac cos b, or c squared is equal to a squared plus b squared minus 2ab cos c. Those are all the exact same. It's just using different sides to work out what this triangle actually is. So there is another way to write it, and this way is used to find out angles with the cosine rule. So this way that I'm talking about is cosine A is equal to b squared plus c squared minus a squared divided by 2bc. So it's just this equation in the box here transposed to look like this, and you can work that out for yourself on the fly if you really needed to, but this is what you would use to find out an angle, because then you can just inverse cosine all of this here to work out what A is. So that's all the time that I have for today on the cosine rule. If you have any questions, feel free to contact me on social media or in the comment section below, and I will see you in the next video.